Hi guys, this is Mark. In this video, we will talk about data paging, an extremely important concept that exists in Backendless, and it has direct implication on data retrieval API. What is data paging? Well, it is an ability to retrieve larger sets of data in chunks or in pages. And you can control how it is retrieved by using some parameters in the data retrieval API. It exists in Backendless for the reason primarily of performance. When you have a very large database or even moderately large database, you will have records that you would need to be retrieving. Retrieving all of the records, which is kind of a natural thing that comes to mind, and we see a lot of questions, how do I retrieve all the data, may not necessarily be the best idea. Again, for the reason that when you present a lot of data to the user on the screen, they simply cannot consume that much data in a single glance. But breaking it up into pages, it improves user experience simply because you can deliver that data much quicker to the user, and the performance of your application goes up simply because retrieving smaller chunks of data works significantly faster than retrieving all of the data. Of course, there are cases when you need to retrieve all of it. Those cases are really in minority and need to be handled with special care. In this video, we will talk about the actual mechanics of data paging, and we will run a few demos where I will demonstrate how to work with the API. But first of all, let's take a look at what data paging means and how Backendless approaches it from the APIs and the parameters that are required to do this. So let's switch to a few slides and learn about data paging. So consider that these blocks are individual records or objects that you would be retrieving from the database. These blocks may be organized in any kind of order because you could apply sorting, you could apply a where clause, you would be retrieving a set of records. So what happens in Backendless is that every single record is assigned an index. That index you cannot see in the actual database. You cannot run a query and see what index each record has. Those indexes simply indicate the position of the record in the data set. And the data set is identified when you run a query or when you simply retrieve data from a table. The very first record has the index of 0, and then it continues on to have where every single record has its own index. And if you're retrieving multiple, let's say 100, then of course it's going to be from 0 to 99. So what happens is when you apply paging, then you would have to specify the page size. And then, for instance, for the demonstration purposes, let's say that the page size is 3. So we will be retrieving 3 records at a time, which is not practical, but once again, this is strictly for demonstration of the concept. And we will talk about more practical approach as we continue in this video. So with page size equals 3, the very first request will retrieve first 3 records, and we specify the offset, or in other words, an index of the first record in that page. And the offset being 0, we're going to get records 0, 1, and 2, as they are highlighted here on the screen. Let's say we want to do a subsequent request and get the next page. Then in that request, we would have to specify the offset of 3, because the first record in that page would have the index or offset 3. And as you can imagine, as we continue, then the third request would have offset 6, and then the final request would have offset of 9, where we would get 2 records. And here, as you can imagine, if the page size is greater, then of course you would need to manipulate the offset accordingly. And the offset does not necessarily need to go sequential. So for instance, if you need to get a page that overlaps, I don't know why you would do it, but it's still possible. So offsets here, 0, 3, 6, and 9, could actually be anything you want, and by specifying page size and offset, you can get pretty much any kind of page or any kind of chunk of data from that data set. Let me illustrate that with an example, once again in the slides, that would be more demonstrative of a practical scenario. So let's consider that we have a data set that has 250 records. This could be a data set returned with sorting, with a query, doesn't matter. So here we have 250 records where the offset ranges from 0 to 249. So let's say we have a client application, and that client application makes a request to get a page size of 100 records, starting with an offset 0. The reason it says 100 here is because in Backendless, the maximum page size that is allowed in a single request is 100, so you can get 100 objects at a time. Don't worry, because it may sound limiting, but it's not, because you could actually retrieve the entire data set with multiple requests, and I will definitely demonstrate how that would work. So here, with that request, where offset is 0 and page is 100, we're going to get the chunk of data that will travel back to the client, and we now have records from 0 to 99. In other words, first 100 records. Then we could make the subsequent request to get the second page, starting with offset 100, and again getting another 100 records. So that page of data travels back to the client, and now we have 200 records on the client side. So then we make the third request, again offset 200, page 100, but keep in mind we have 250 records and we already have 200 of them. So what's going to happen is that now we will return, the server will return 50 records that go from offset 200 to 249. So here what we see is that we received less than 100 objects, and that is the sign that we have reached the end of the entire data set. So whenever you get a page back and the size of that page is less than your page size, that means you have retrieved everything. If let's say hypothetically we had 300 records, then this would return all 300, and then the subsequent request with an offset of, let's say, 300 would return an empty collection. That means you have reached the end of the data set. So what the important thing here to keep in mind is whenever you retrieve a page of data and you got less than the page size, you are at the end of your data set. So with this, now we have the entire data set on the client side. Let's return to Backendless console and take a look at how that API would work, and then we'll run a few examples that would demonstrate the usage of that API in action. So here I am on the page of basic data retrieval, the same page that we have worked through all along. And if we go back to the logic of this page, notice that in the load table object block, and if you are using code, you will have a request to retrieve data objects, there is a parameter of page size. And right here I have 100. And see what happens if I make it 200, for instance. So we try to retrieve more data than maximum allowed page size. I will run this page, and we will open inspect window and take a look at the network traffic. So let's reload this page. And notice that this find request, it ended up with error. So it is highlighted in red. The error code is 400. And by taking a look at the response, notice that the error says invalid page size. Page size cannot be greater than 100. So Backendless is aware of the, well, of course it is aware of the limit that it has, but it tells you that you're using a page size that is greater than what maximum allowed size is. So then the question is, how do you work with the API to do the retrieval of the data if you need more than 100, or how to implement it where you basically use paging API. In order for you to experience data paging out of the box, we prepared a couple of things that are available in Backendless Marketplace. Let me walk you through the process of getting it set up. Number one, we will need to install a few UI functions. This is a new concept. We have not done it yet, and it is actually very straightforward and kind of cool. So click in the UI builder, click the logic tab, and then switch to functions right here. And functions are reusable logic that you can create by yourself, or you can install it from the marketplace, which is exactly what we are going to do. So click on this button, on this icon that says install from marketplace, and select other as the category. You will see that there is a function pack called data paging functions right here. So make sure it is selected and click install. That will install a couple of functions that are general purpose. You can use it in your applications. That will give you an ability to use data paging in your application. So the functions are already installed. Let's switch to user interface and create a page. Again, that page will be created from a template that is in the marketplace. So move the mouse over this area and click the new page button. In here, you can give it a name. Let's say it is going to be data paging, and create from drop down. Make sure to select marketplace. The templates are going to be loaded, and the one that you need to select is going to be this data paging lecture load more. Make sure to select load more because there are two for the current lecture. This one, we will get to it a little bit later. So select the one that says data paging lecture load more. Click create. And the page is created, and this page demonstrates data paging for a table that I believe has 2,500 records, so there are plenty to page through, and all the functionality is already in place. But first, let's run the page and see what's going on there. Once the page is loaded, right-click, select Inspect so we can see the network traffic. Make sure to select the Network tab in the DevTools. And here you see that the first page of 100 records was already loaded. Whenever you click Load More, you can scroll all the way to the bottom and click Load More. Another request is made, and you can see right here, click this Find. It made the request where the offset is 100 and the page size is 100. So now you can continue scrolling. So now we have 200 records. Click Load More again. There's Find Request. This is options. So this is the actual API call. Notice that the offset is 200. So you can continue clicking, and it will continue loading additional pages and update the UI accordingly. So data paging is working exactly as it should, and with this approach, load more button, you can load additional pages. And of course, in the UI side, you can add additional logic, where as the user scrolls down of the page, you can preload or load additional information, sort of like infinite scroll, or you could have a traditional pager with the page sizes, whatever you'd like. That's going to be completely up to you in your application, but that's more on the UI side. Here we're talking about using the API to retrieve additional data in terms of paging. Here on the actual page, you will see that the functionality, if we select the page itself and go to its logic, in here we use this load data with paging function, and this is the function that was installed from the marketplace. Unfortunately, you cannot see the logic of this function, but I will walk you through it anyway so you can see exactly how I structured that API. And maybe I submitted a request to the product team to provide an option to publish functions into the marketplace where you can actually see the logic, which I think would be kind of cool. So hopefully that ticket will be implemented. Anyway, so all of the logic for the initial load is right here on the page. That retrieves the first page of data, and we just set it to the repeater, and the repeater just renders everything on the screen. And we're loading data from the customer table. Then when the button is clicked, if we go to the logic here, then we use load data paging function again. We provide page data because it needs the data model, and whenever we get this data, we combine with what's already on the screen by getting it from the repeater and just updating the repeater. So the logic here is very, very straightforward. That's all it takes as far as using this API. The actual API to work with the database is sitting inside of this UI function. So I will switch to another app where I actually put together this function so you can see how I implemented it, because it will give you an idea how to operate with the offset and use the actual underlying database API. Let me switch to that other app, and here I am. This is the actual source app. So let's take a look at the implementation of those of that function that loads data with paging. In logic, if just switched, well, you cannot switch to logic because you don't have it, but here this is my function, load data with paging, and let me show you the actual logic in here. So this is the function itself, and in here I'm using sub-functions just because it makes it easier to apply logic and becomes more kind of granular. So there are three steps that I'm doing. First, I'm initializing the offset variable, because the offset variable needs to have this value throughout the entire life cycle of my page, because I load initial data set when the page is loaded, and then upon clicking the load more, I need to know what the current offset is, just so I can load additional data. So initially, well, in my data model is where I have the property offset. As you can see, I'm retrieving that property and I assign it to a local offset variable. If this is the first time an offset is not there, I just initialize offset to 0, because that's going to be the very first request. After this, right here, so we did offset var, then we do load data subfunction. And this is the load data. And in here, as you can see, this is where the actual loading of that current page happens. As you can see, my page size is set to 100, and in the page offset, I'm passing this offset variable. So if we are doing it for the very first time, then offset is 0. Then in here, we load, we can pass in where clause and all the other parameters if they are specified. Right now it is not important, but whenever this data is loaded, we put it into a variable called loaded data. And you will see in a second why I'm putting it in the variable, and the answer for this will be in that third subfunction, adjust page data state, which is right here. Okay, so in here I'm checking if the length of the data that I got is less than 100. Remember from the very start of this video, we were talking about how to detect if you are at the end of it. So if it is less than 100, then we know we are at the very end of our data set and additional paging is not needed. We already loaded all the data. So to report to other part of the application that we are at the very end of it, I do have a variable in my data model, which is page data, that I set this property loading data to false. And what's going to happen is that load more button, it is bound to this loading data variable. So as soon as it is false, then the visibility of the button goes away and load more is gone. However, if the size of loaded data is 100, meaning that we got the entire page, then what I'm doing is I'm updating the offset variable in data model by taking the current offset and adding the length of the data that I loaded. I could have safely added 100, but here this is kind of a more visual that I'm taking the data that I got and I'm updating my offset. So what this means that second time when the entire logic here and function runs, the very first thing that I will do is I will initialize offset variable, which is right here. So I'm retrieving the same offset from data model, and at this point it's going to be 100 second time that I run, simply because I updated it right here. So now that my offset is 100, whenever I retrieve data, then offset is going to be 100. In this way, we continue going through the entire data set. And that's how paging is implemented here, really inside of this one function that does everything. If you want to replicate this, I hope you got the actual idea and the mechanics of how it works here. If not, please leave a comment and we'll just write up an article somewhere in our support forum that really describes kind of a recipe for doing this. And that's not going to be a problem. Anyway, here's the second thing that I wanted to demonstrate. And the second thing comes as a request rather frequently from users that say, how do I load all my data? And what I did is I implemented another page template that does the same thing as this. But instead of clicking load more, it loads everything at once, and then the entire data set is displayed in UI. And for this, I will switch back to my other application where I can install a page template, and then I recommend you to do the same. And you can actually see how that works and the difference that it makes in terms of the user experience. So let's switch to the other app right here and create another page that we will call data paging preload. This indicates that we're preloading all the data at once. Again, from the marketplace, select this template that says preload all. Click create. And in here, if you go, there is no load more button. So if you select this page and go to the logic, notice that in here it uses another function that was also installed called load all objects. And then what this function does, it will loop through the entire data set until it got to the very end and return all of those items to be rendered into the UI. This is not recommended. This is done strictly for demonstration purposes. Whenever you build your UIs, do not load all the data. Your users will have to sit and wait while it gets all the data. You'll be returning a very large data set, especially we see in Backendless people have databases with millions of records. So if you start implementing it for a very large data table, then you're literally going to be blowing up the memory in your browser and a mobile device. That is just terrible user experience. So loading all the data needs to be done only in very rare occurrences when it really makes sense. But for display purposes, use paging, because you will just be doing great service for your users. But anyway, let's run this page and see how that actually works. So here I will run this page and notice that it does all those find requests, and basically it was looping through and it made like maybe 25 so the entire data set is 2,500 records, so it made 25 requests to get 100 objects at a time, and now we have the entire data set of 2,500 records all displayed in the UI. And that's really the difference, is that you either do it all at once or with paging. Again, I will go through the logic of that other function so you can see how I implemented it. If you were to do this, you will not be able to do it simply because the functions that you installed from the marketplace, you cannot browse to them, you cannot see the logic, but I will go over that logic so you can see how it is implemented. So back in that other source app where I was creating it, there is a page that I have called load all data, and that's the one that doesn't have load more button. In the logic of this, it's going to be exactly the same. I'm using the load all objects function, and inside of the actual function, load all objects, here's the logic that I use to load everything from a single table. And here it's more compact because there is no intermediary state. We get in, we load everything. And let me walk you through of the logic right here. So number one, I set a Boolean variable called loading to true. And then I create a list called all customers. All customers variable will be accumulating the data as we load it. Then I also create a variable called offset, simply because with every single iteration in our loop, we'll need to modify this offset. Then I start the loop, and I use a while loop, and it's going to be repeating while the loading is true. And then as soon as we get to the very end of it, the loading variable will change to false. So this loop will continue fetching data. In here, I use load table objects to get 100 objects for the offset in the current iteration, and this one starts at 0. We got this data, put it into a variable called current batch. Okay, then I take this current batch and I can combine with what I already have in the all customers list. So this all customers list will just continue to grow with new data that arrives. After that, I modify my offset by adding 100. So this way I will just continue adding 100 for every new page. Finally, I have a logic to check if I'm at the very end of my data set. And in here, if the size of the current batch, the one that we got right now, is less than 100, then loading is false. We are at the very end of it. And when the loading is false, we get to the return value and we return all customers. And that will include absolutely everything that it loaded from the server. So fairly simple logic, and in here you'll be able to replicate it by yourself simply because you see the entire logic on the screen, and it should be very straightforward. Again, I want to reiterate that data paging is there not to make your life difficult. It is actually there to make your applications to perform better and faster and provide better user experience. It is okay, and it is actually advised to make more frequent calls that execute faster and return less data than having some function that just retrieves a lot of data and returns a lot of data back to the client. So keep that in mind as you build your applications. I do hope that you found this useful. Data paging is extremely important. One other thing that I want to mention is the concept of paging applies no matter what other parameters you use to load data from the database. Whether you have where clause, whether you specify properties to include or exclude, whether you use sorting, you will end up with some data set. Keep in mind that the data set is on the server and it will have those indexes, and that's what you will be paging through. So it's not necessarily data as it sits in the table. It's sort of like a virtual set that is identified by a query, and then you will be paging through that data set. So, and that may not be very obvious, especially like with sorting. So whenever you run a query, and let's say it has sort parameters, there will be that virtual data set created on the server, and you'll be paging through the data set. So that, hopefully that is clear. Thank you for watching this video, guys. I know this is probably a more difficult one than any other ones that we have already gone through, but it is an extremely important concept. If you have any questions, please leave a comment and provide any feedback. It is going to be much appreciated. Again, thanks for watching, and as always, happy coding.